The coefficient of static friction between a block of mass m and an incline is mu s equal to 0.3. What can be the maximum angle theta of the incline with the horizontal so that the block does not slip on the plane? So theta is angle of repose when block does not slide. So we can say tan theta is equal to mu s. So theta equal to tan inverse mu s is 0.3. Now, if theta changes to theta by 2, then we have to find out what is friction. So friction is equal to mg sine theta. So friction will become mg sine theta by 2 when theta changes to theta by 2. A horizontal force of 20 Newton is applied to a block of mass 4 kg resting on rough horizontal table. What can be said about the coefficient of static friction between the block and the table if block remains at rest? Take g equal to 10 meter per second square. So here friction must be equal to force applied because friction is self-adjusting force. And the second point is we have to find out the coefficient of static friction. So we know that coefficient of static friction is given by mu equal to friction divided by normal reaction. So here friction is 20 and normal reaction will be mg. So m is 4, g is 10, so it will become 40. So mu equal to 0.5. So in fact, mu must be greater than or equal to 0.5. Next question. The coefficient of static friction between the block of 2 kg and the table is 0. What would be the maximum value of m so that two blocks do not move? The string and the pulley are smooth and massless. Here we can say tension must be equal to friction if block is not moving, and friction equal to mu times normal reaction mg. So we write it as mu times m is 2 into g. G is 10 and mu is also given as 0.2. So 0.2 into 2 into 10. So this will become 4 Newton. So this is value of tension. Now for this block, since this block is also not in motion, so we say tension equal to mg and we have to find out m. So m is equal to T upon g. T is given as 4 Newton. G is 10 meter per second square. So this will give 0.4 kg. And that's our answer. Let's go to next question. Next question says, the coefficient of static friction between the two blocks shown in the figure is mu and the table is smooth. What maximum horizontal force F can be applied to the block of mass M so that the blocks move together? So here, the frictional force between the two blocks will provide it the acceleration. So we can say friction equal. We are talking about smaller mass or mass small m. So frictional force will provide the acceleration. Frictional force will be mu mg, which will give, suppose acceleration of 10 is a, so ma. So from here we can get a equal to mu g. Now, since this a is common acceleration to both blocks when force F is applied, so we can also say F equal to capital M plus small m times A. So here our concern is to find the expression for force. So F equal to capital M plus small m times A, and A is equal to mu G. So this is our required answer. Now, if we wish to draw free body diagram, so it can be drawn. So its weight will be downward. Its normal reaction will be like this, N1. And here there will be frictional force. So frictional force will provide the acceleration. Frictional force will be in this direction. So that I have written here, that F equal to mu mg, and net force will be frictional force only. And due to that, there is acceleration in first body. So similarly, for second object, if we want to draw the free body diagram, so it can be drawn like its mg will act downward. There is one force F, which is acting in this direction. Normal reaction due to this mass will be suppose N1, and the reaction force of this block, this will be suppose N, and there will be frictional force on this in the opposite direction, Fr, between these two. So frictional force will act here in this direction. For this body, it will act here, and we will get this span. So the solution is this much. So it is not necessary to analyze all the things. Thank you for watching.